Guys, good morning. Listen, today we will have a meaning about something new. We call it Avogadro's number. For any gas that is moving and have the importance for getting the total enough amount of energy, we said here that there is something we call it 1 mole of a substance. 1 mole of a substance, it's like a quantity. This quantity for the substance here contains a specific number of the particles which are equal to the number of Avogadro's number. This number is a constant number, okay, and the mass here for this entire number in grams is equal to the molar mass of the substance. The molar mass of the substance here is different from an object to another because you are getting the mass number for the compound. So as an example, H2, if I want to get the molar mass, it would be 2 because you are multiplying 2 atoms by 1 of their atomic mass. So we said here 1 mole of any substance contains as many particles as there are in atoms in 12 grams of the carbon 12. We take here the carbon as a base, where we can see that the amount of the particles, they are equaling the 1 mole for any comparing for the carbon 12. Number of particles in a mole is Avogadro's number. We call the Avogadro's number Na, and this number is a constant which equals 6.02 multiplied by 10 multiplied by 23 mole minus 1. So if I want to get the number of the moles, which is N, it equals for me the number of the particles over the Avogadro's number. So for the unit that I'm using here for these particles, we call it here the atomic mass. The atomic mass here scale, it defines one atomic mass unit. The one atomic mass unit here equals 1 over 12 of the mass for the atom of the carbon 12. So we are measuring this carbon material or carbon atom as a standard for comparison between any atom and also the carbon atom. The molar mass here for the any compounds, it's the sum of the atomic masses of these atoms and making up the molecule. Like as an example, CO2, the C here has a 12 of their atomic mass, oxygen has 16, so we say C plus 2 multiplied by O. A C here is 12 plus 2 multiplied by 16, which gives me 45 gram over mole minus 1. Number of moles always equals for me the mass by the gram or the kilogram over the molar mass, which is transferred to be the molar mass. You see here, estimate the number of the atoms of gold when we have 1 kilogram of the gold, and he gave for us the shape of the atomic mass and the mass number. So the molar mass for the gold, it equals for me 197. Okay, for the gold, so a 1000 of gold equals 1 kilogram, which contains and that means that you have to change it into the molar mass. So molar mass here equals the mass over the atomic mass. Mass over the atomic mass. The mass here is 1000 over the molar mass, which is 197, which gives me at the end nearly 5.1 mole of the atoms. So you got here the number of the moles, and then you can get the number of the Avogadro's number, which we can see here. Each mole contains 6.02 multiplied by 10 power to 23 atoms. So the number of the atoms in 1 kilogram of gold is equaling the Avogadro's number multiplied by its moles, and it gives me in the number of the atomic number of atoms inside the gold. This is the entire work that we have to go through. I have here a classwork, you have to finish it. Once you finish, submit your work. Thank you.